Hey everybody, it is Ms. Calkins, and today we are continuing still with our quadratics unit. This is a very important piece of the quadratics unit, and we're going to be finding the x-intercepts of quadratics. So an x-intercept, like the y-intercept, is where a graph crosses the x-axis. The x-intercepts of a quadratic are known as the zeros or the solutions of the quadratic or of the system that we're working on. If we were in class together, you would hear me say zeros and solutions over and over and over because it's so important. And on some of the things we're going to be working with next week, we're going to be talking a lot about zeros and solutions. So there are a couple of ways to find the x-intercepts from a quadratic. One way is to actually graph the quadratic and to see where they cross the x-axis if they do. Some quadratics are not going to cross the x-axis. You can always plug this into Desmos calculator, which may be an option for a lot of you, and it might be the method that you choose. It might be the easiest method for you. Go to Desmos graphing calculator, type this in, the parabola should show up, and you can see exactly where it's going to cross the x-axis, and you would answer that as an ordered pair if that was what the question was asking. Okay, so from this one, if you were to fill in this function table, you would plug each one of these values in for x, both places that you see the x, work out the equation, and then report your corresponding y value. So when you put a -6 right there, that becomes a positive 36, just to kind of review, because that would be -6 times -6, 6 times -6, then you would subtract 36, and then you would add 5. So when you plug the -6 into the quadratic, y is going to be 5, and then you could plug each one of those in one at a time to get your corresponding y values. So I have -5, 0, -3, -4, -2, -3, -1, 0, 0, 5, 5, 12, and then 2, 21, etc. So again, I kind of sped that up, but if you were doing this by hand, you would plug each one of the x values into the equation for x in both places, work out the equation, and that would give you your corresponding y value. So from there, then you could graph these ordered pairs over here and kind of see what your quadratic is going to look like and where it would cross the x-axis. So I know this is a sketch, so it's not going to be perfectly to scale. Your Desmos graphing calculator would be a much better option for this. So if you do 1, 2, 3, 4, 5, 6, about right there would be -6, 5. -5, 0 would be right there. -3, -4, that would be -2, -3. Let me move that down. -1, 0, and then 0, 5, and then 5, 12, etc. So I know I'm missing a point right there for -4. I didn't plug that in, but that's okay. We've got enough to see what we need. All right, so your parabola is going to look a little bit like that. Of course, it should be more of a U shape than mine. So here's a couple of important features. First of all, this is your y-intercept. And you should be pretty familiar and comfortable with y-intercepts because we've talked about those a lot. These 2 points right here are your x-intercepts. It's where that graph crosses the x-axis. Sometimes you'll have 2 x-intercepts, sometimes you'll have 1, and if your parabola was graphed up here, it would never actually cross the x-axis, so you would have no x-intercepts. So if I wanted to name those 2 ordered pairs, that would be -5, 0, and this would be -1, 0. Now, you could have pulled those out immediately from the table because anytime you have the x-intercept, the y value of your x-intercept is 0, and that's very important to remember. So anytime you're talking about the x-intercept, that y value is going to be 0 because it's going to be plotted right on the x-axis, and if something's plotted right on the x-axis, the x value is 0. So again, you could plug this into Desmos graphing calculator, see where it ended up on the x-axis, and recorded your answers from there. Okay, so that's method 1. Method 2 which is the method that we're going to be focusing on a lot in the next few sessions, is to find the x-intercept from the actual equation without having to graph it. So I do have these exact same notes that I'm using posted on Canvas, and I have these exact same steps listed out. So if you wanted to see the actual steps that I'm talking about, you could see those on Canvas. I'm not going to take the time to write them out here. The first thing that you want to do, if you're finding this from an equation, you want to factor that quadratic. That's why we spend so much time factoring, because this kind of comes all back full circle. So if you were going to factor this, again, we want to know what numbers multiply to give you 5 and add to give you 6. And those numbers are 1 and 5. So you would write that as n plus 1 and n plus 5. Okay? Nothing new about that. Now, here's the part that's going to be a little bit new. It's going to be a little bit weird at first, but it's actually pretty simple. If you have the x-intercept, this number has to be 0. So what I'm going to do, I'm going to set each one of my factors equal to 0. Now, I've got n right there. That actually should be a y, but I'm not going to take the time to change it. So just pretend like, or x, just pretend like the n's are x's. So I'm setting these both of the factors equal to 0 because if we have our x-intercept, the y value is going to be 0. So the n for this one, you would subtract 1 from both sides, is -1. And the n for this one, you would subtract 5 from both sides, would be -5. And so these are the x values for your x-intercepts. Now, if you actually recorded this as an ordered pair, that would be -1, 0, and that would be -5, 0. That's the same intercepts that we had from the other problem. So your two answers, again, pretend like I'm going to interchange these back to x. I shouldn't have had the n. So pretend like all those n's are x's. So that's what you're going to do. So for number 2, and I actually do have x's there, so that's good. The first thing we're going to do is factor it. So I'm going to think, what two numbers give me a product of 28 and a sum of -11? Since this is positive and this is negative, you need to remember both of these numbers has to be negative. So it's going to be x minus 4 and x minus 7. So those are your factors. Now I'm going to set each one of these factors equal to 0 because I'm trying to find the x-intercept. So I'm going to have x minus 4 is equal to 0 and x minus 7 is equal to 0. And then we just solve for x. So the x value for this x-intercept is 4. The y value would be 0. The x value for this x-intercept would be 7. And the y value is 0. Okay, a couple more examples just to kind of go through these. Your homework is going to look like this, your assignment rather. You're going to give me both x-intercepts if there are two. Sometimes there's just going to be one, and if there's not an x-intercept, you would just put none. You would write your answers or type in your answers like I have here, x equals and x equals. So the first thing we're going to do is factor this. I want to know what two numbers multiply to give me a -24. And add to give me a -5, and those two numbers are going to be -8 and +3. So that's the factorization of our quadratic. I'm going to set each one of those factors equal to 0 to find my x-intercept. So x minus 8 is equal to 0, and x plus 3 is equal to 0. Add 8 to both sides, so your x value for the x-intercept for this is going to be 8, and your other x value for this intercept would be -3. Yes, that's right. There's a misprint on the notes that I'll have to go back and fix. Okay, but there is a misprint on the notes. I'll have to go back and fix those. All right, the last one. If you think of two numbers that give you a product of 9 and a sum of 6, those two factors are going to be x plus 3 and x plus 3, okay? These are the exact same, so you only have to set one of those equal to 0. So that would be x plus 3 is equal to 0. Your x value is going to be -3. Now what this means is there's only one x-intercept for this. Because you have the same factor. So this is only going to touch the x value one time, okay? So that's kind of a sum of everything that we're going to be working on for the next couple of days. So please come to Zoom if you have any questions, and I will see you later. Thanks. Bye.